Okay, now that we've learned all the transformations, let's look at some examples of functions that contain multiple transformations all at in one. So let's say given y equals 2x squared minus 2, start with the graph of, when it says that, it's asking for the parent function. So our parent function here is going to be x squared. So again, we're looking for either x squared, x cubed, square root of x, or absolute value of x, based on the four parent functions that we're starting with in this unit. Okay, then it says, and then blank vertically by a factor of 2. So what are we doing here? With this vertical is talking about stretch or shrink. And so that's going to be the number in front. And that number in front is going to tell us if it's bigger than 1, we're stretching, and if it's less than 1, we're shrinking. So obviously this is bigger than 1 with that 2, so this is going to stretch vertically by a factor of 2. And finally, shifts, that should say shifts 2 units blank. So which direction is this other 2 going? All right. So we need to determine, is this minus 2 inside the function or outside the function? So remember, we're doing that by circling the parent function. Our parent function is x squared. So we're going to circle x squared. Is that minus 2 inside or outside? Well, that obviously is outside. Okay, and if it's outside, that's telling the y value what to do. So our y value, again, that's your up and down. You're using the sign that it gives you. So minus 2, y value is going down. Okay, and again, this is from the origin. Lastly, what's our shape of x squared? We know, and we can see with all these examples and multiple choice here, that this is going to be a U shape, but you just still need to know that. So we are looking for something that shifts down 2 units and stretches vertically 2 units. So first, identify your origin. Obviously, all of these have the origin kind of at the middle here, which is great. And then from there, figure out your shifting. So the shifting here went down 2. Okay, this one went right 2. This one went up 2. This one went left 2. So this is kind of an example of what you might have in your homework. And basically, we can figure this out by just the shifting. We want this to go down 2. So the only one that went down 2 is our first one. You can double check the stretch, though, again, by looking at your kind of vertex or your reference point there. And normally, remember, it would go up 1, right 1, but this one is going up 2, right 1, up 2, right 1. So that tells you, or you could think right 1, up 2, however you want to do that, okay? So this is telling you how far up you're going for every unit, or for 1 unit to the right, okay? And I want to be clear, you can't keep going and saying up 2, right 1, up 2, right 1. It does not work like that with an exponential, but it does tell you the relationship between that middle point or that reference point and 1 point to the right, okay? All right, so A is our answer here. We pretty much could see that by just going down. Let's look at another example. The graph of f of x equals negative x plus 2 cubed plus 3. Negative x plus 2 cubed plus 3 can be obtained from the graph of. It wants to know what graph are you starting with. Okay, so here, this can be obtained from the graph of, this is x cubed. So if I take off the minus, the plus 2, and the plus 3, all I have left is the x cubed. Okay, then it says, by first reflecting the graph over. That negative in the front is going to be your reflection. If it's in front of the parentheses or in front of the parent function on the outside, that is reflecting over x. If it was on the inside, that would be reflecting over y, and it would look like this. I just want to show you real quick. It would look like this. Okay? It would be like inside that parentheses. That is obviously not the case here. So this is going to reflect over the x-axis. Then shifting the graph 2 units, Is the 2 inside or outside? Okay, so if you circled x cubed, that plus 2 would be inside that circle. So plus 2 on the inside affects the x values, and you're doing the opposite because you're saying x plus 2 equals 0. And when you subtract 2, that's telling your x value is negative 2. Okay, so now that means that you're going to go, where's x negative 2? That's to the left. So we're shifting the graph 2 units left. And then shifting 3 units, which direction? This plus 3 is on the outside. That's telling your y values what to do. So plus 3, we're going with the sign that it is. So plus 3, y values are going up 3 units. So where's y3? It's up 3. Okay. Then shifting 3 units up. Okay. All right. I think what I would suggest first is to get the reflection in. So what does our parent function normally look like? Our parent function for x cubed is normally up on the right, down on the left, with the origin here in the middle. But if you have a negative in front, it's flipping those two things. And y'all remember in behavior, this still applies. Negative tells the right side to go down. The degree is 3, that's odd. Left side does the opposite. So we're looking now for the right side to go down and the left side to go up. Let's look at that first. So here we've got the right side down, left side up. That's a possibility. Here we have our right side going up and our left side going down. That would look just like our normal parent graph, so that's not going to be it. We need the flip. Here this is down on the right, up on the left. That's a maybe. Down on the right, up on the left. So that's a maybe. So now we've eliminated one of the options. From here, I want you to find kind of the flat point of the remaining 3 graphs. So here's our flat point. Here's our flat point. Here's our flat point. And we want to do our movement. So we are shifting 2 units left and 3 units up from the origin. So we need from the origin 2 units left, 1, 2, and 3 units up, 1, 2, 3. Clearly, this is not that flat point. So A is not going to be it. Let's look at C. From the origin, 2 units left, 1, 2, and 3 units up, 1, 2, 3. This looks like it is correct, but let's check the other one. So we've got 2 units left from the origin, 3 units up, 1, 2, 3. Is that point the flat point? No. So it's going to be C. Okay? All right. Last example here. And then we'll look at a couple more where we're doing the reverse. All right. We are starting with the graph of f of x equals negative square root of x minus 5 minus 1. Negative square root x minus 5 minus 1. Okay, this graph can be obtained from the graph of, what's the parent function? Parent function here is going to be square root of x. Okay, by first reflecting the graph over what axis? So it's asking about the negative side in the front. Is that negative inside or outside? If it's outside, it's x. If it's inside, it's y. So this negative is outside, and then we have the radical. So this is going to be x-axis. Then shifting the graph 5 units which way? So this 5 minus 5 is on the inside. So x minus 5 set equal to 0 gives me an x value of 5. Okay. Gives me an x value of 5. Which way is that? Where's x5? That's right. Okay, so we're going right 5 units. And then shifting 1 unit. Is that inside or outside? That's going to be on the outside. Okay, inside tells your x what to do, but the opposite direction. Y is on the outside. That tells your, or the number on the outside tells your y what to do. That's going to go in the direction it says. So negative 1 goes down. So this is going to go down. Okay, So I actually want to tackle this opposite way. So let's first do our shifting. It really doesn't matter. You just need to know in your mind which way, when you do your reflection, what's actually happening. So let's do our shifting first. Shift graph 5 units right and then 1 unit down from the origin. So here's the origin, 5 units right. I know this is not easy to see, but 1, 2, 3, 4, 5, 1 unit. That's a possibility. Let's look at our next one. From the origin, 1, 2, 3, 4, 5, down 1, that's a possibility. Here's the origin, obviously not gonna work, so C's not it. And then D, 1, 2, 3, 4, 5, down 1, that's a possibility. Okay? All right, so now we've got it down to 3 options. Which one of these shifts is correct? So that means you need to know the parent function graph. That is a ray off to the right-hand side in the first quadrant, and the flip. So when I do the square root of x, but with the negative in front, this is reflecting over the x-axis. So the x-axis, if this is the x-axis and this is the origin, we're going down like this. So which one of these graphs goes down? Well, A looks like it's in the same square root of x direction, so that's not going to be it. B is kind of taking the graph and going this way with it. Well, that's reflecting over the y-axis, not the x. So that's not it. D is truly giving us that down and to the right that we need. Okay, so D is going to be our answer on that one. Highly recommend practicing with your reflections because that's going to be more common than probably the stretch and the shrink. And obviously the translations of moving it up, down, left, right, remembering that inside controls the X, outside controls the Y value, okay? All right, let's look at the reverse real quick and see what happens if I tell you what the graph looks like. Can you come up with the actual function itself? Okay, so this is given the transformation and the parent function, write the resulting function. So I'm telling you that the shape of the graph models the shape f of x equals absolute value of x. Hold on. One moment. Okay, I'll do this in another video. Catch the next video.